Okay, in this video, we'll talk about some common threats to IoT systems. So first of all, you need to know that there are a plethora of threats to IoT systems. So actually, since you have been using internet for many years, you know that even for internet, it has many threats, many cyber attacks, right? And for IoT, it is built based on the internet, and it has many physical devices. In that case, the number of threats will be even higher. So in this section, we'll talk about some common types of threats, including the denial of service, serial, privacy, whole, and physical attacks. So for the IoT attacks, the IoT systems may be comprised of complex heterogeneous subsystems that combine wireless internet computing technologies and need not subscribe to a single standard or specification. So for example, they may be using Wi-Fi, they may be using Bluetooth, they're using different standards. So with this scene, we will arrange our discussion based on the 7 layers of the OSI model. So as OSI model is, if you are a computer science guy, you should have seen this somewhere. Basically, it talks about divide the communication of the computers into 7 layers. So actually, I have added an additional reading to help you get familiar with this model. But just basically, it takes from the physical elements, for example, the fiber, the wireless, all the way up to the applications. Basically, it deals with the functioning of the network from the bottom to the top. For our discussion, we will arrange the attacks according to the layer on which they can happen. Okay, in the following, we'll talk about the types of attacks that may affect IoT systems relating to the layers of the stack here, the same stack here. And also, we'll talk about the countermeasures in the next video. Okay, the first one is denial of service, DOS attacks. So basically, first of all, it is a broad category of attack. Basically, if the attacks can make the function stop, out of function, something like that. So it can be roughly categorized into denial of service attacks. It is most common and easier to implement attacks on IoT systems. So for any wireless network, we have the jamming, we have the flooding and collision. Yeah, we'll look into this into more detail. At the physical layer, jamming is popular denial of service. Jamming, so as you indicate, as you can imagine. So if it is, for example, if it is a wireless network, so if the bad guys creates too much wireless communication in the network, then basically your Wi-Fi is not working, right? So it is kind of a denial of service. It can be either intermediate or constant jamming, both of which have a great impact. So the number of devices required to effectively perform such an attack may be a small portion, maybe as small as fraction. So one malicious node can be enough to disrupt the intended operation. For example, if your laptop is hacked, so it is trying to send out the Wi-Fi request, well, like crazy, then basically your home Wi-Fi will be not working. So for the data link layer, collision attacks are common DOS attack, whereby an adversary will intentionally violate communication protocol in an attempt to generate collision. So this will require the transmission of any package affected by the collision. This contributes to unnecessary consumption of device and network resources. So we mentioned packets here. So just to let you know, so for your information, no matter whether you're using the wireless or wire cables, so basically your information, your data are sent in standard packets, right? So they are of a standard size. So if your data file is large, it will be separated into a large number of packets. So for the collision attack, so basically what it will do is, for example, it may change a small part of the packet, which will lead to an error in the checksum. Checksum means that basically change the small part of the packet so that it violates the standard of the packet, so that the packet needs to be reset, right, or transmitted. So in that case, if we keep doing this, then you can imagine that the channel or the atmosphere is filled with packets being transmitted and retransmitted. So basically, there are collection of the packet. So after some time, so basically the data link is overwhelmed. For the transport layer, it is susceptible to the DOS in the form of flooding. This attack is as simple as sending multiple connection requests to the device, agent, and server. So just a background information here. When your laptop is sending message or sending files to a server, for example, server and your laptop, they need to create a connection first, connection request first. Yeah, basically they need to shake their hands, knowing that, okay, I'm going to send a message to you, I'm going to send you a file, something like that. What the flooding does is that it sends multiple connection requests from your laptop to the service. So, okay. So because the resource must be allocated to handle requests, overwhelming with material requests will quickly deplete the resources. It's very for highly constrained IoT devices. So in that case, basically if too many connection requests is received, then the resources of the server, maybe server is very strong, but let's assume this is an IoT device, then it will be overwhelmed very quickly. So that's called flooding. Basically, we need to create many connection requests. And another way is the desynchronization. So a pair of devices, for example, might be forced into a synchronization required protocol by disrupting some of the packets being transmitted between the two devices and maintaining correct timing. So it will also consume the resources. Yeah. So because we are not focusing on the computer science part in this course, so what you need to do is to know about the name of the attack, where it happened, and also if I give you some description like this, you should be able to identify what kind of attack. That's more than enough for this one, for this course. So know their name, know how they work, and be able to distinguish. For the application layer, it is also substitute to a path-based DOS attack, whereby attacker may insert various or replay package into the network. So what it means is that, so if for your software, it just keeps sending out packages, right? Sending out thousands, maybe millions of packages an hour. So it just take out the energy and bandwidth consumed by forwarding the nodes. So if this is your laptop, it is attacked. It is an application is attacked, so it just send out the package, right? Another packet, and for the packet, it needs to be routed, right, to another location. In that case, the nodes connected to your laptop, if it is not very capable, so it will be overwhelmed. So basically, this node is not working. So that's what we call denial of service. Okay, for the severe attacks, so it's very simple. The principle is very simple. It is described as an attack of malicious code taking on multiple identities. So usually, for your laptop, it should be associated with you, right? But if it is infected by severe attacks, it will try to, take other identities. This node can then launch a number of the tests, which could include negative reinforcement, stopping the behavior of a voting scheme. For example, this attack is most effective at a higher layer of the communication protocol stack. So let's look into more details. So at physical layer, the spurious attack is performed by compromising a natural device and fabricating a new one. Basically what it means is that it creates some identities which does not exist, or it just pretends to be another device. Identities are therefore acquired either through theft or fabricating of new ones. The malicious device can then behave as it was a number of devices participating at different points in the network or systems. So this is especially common for the voting scheme. So nowadays we have some entertainment competitions, right? Basically, you need to vote for the favorite actor, actress, something like your model, your idol, right? In that case, if some people actually wrote some malicious code to launch something like this. Basically, usually it is for a device, for a laptop, you can only vote once for your idol, right? Because it will lock your IP or mess. But if you, as a bad guy, he may know some knowledge like this, and he may launch a CPU attack. Maybe not attack, CPU strategy. Basically, he can disguise his device as multiple device with different IP address, something like that. So he can vote for his idol using the same laptop for many times. So at the data link layer, CPU attack has two variations: negative reinforcement and stuffing the below box. Basically, data aggregation is implemented in many low-power IoT systems to reduce power consumption. If a device is continuously providing a large amount of inaccurate data, then an accurate data packet returned by the network will be corrupted. Similarly, voting scheme may be corrupted by the CPU attack. Malicious codes various identities can mean that it can stuff the below box in its favor. At the network or routing layer, a spurious attack can be used to compromise multi-path routing schemes. If the information provided malicious code and its multiple identities is taken account into the routing tables or nodes, then decisions taken by the nodes or route message to the other network members may be at risk of failure. So to summarize, for the spurious attack, what it does is to generate multiple identities. In that case, you can consider it generates multiple nodes in the network in the favor of the bad guy. In that case, if this network, for some applications, you need to use the voting scheme. For example, we don't want to go to too much detail, but for some routing schemes, the voting basically you will count the number of nodes doing something, right? In that case, if CPU attack is there, then this forced or generated identities will affect the result of the voting. Then the behavior of the network will be changed according to the bad guy. So privacy attack. So this is maybe more familiar to you. For the privacy, there are some typical methods that is here. The most obvious attack of privacy is by monitoring and eavesdropping. So so these two terms are straightforward. So sometimes you have seen this in movies or for many times. So two friends are talking to each other, then another guy is just getting close to use his hand to create the comb shape to try to listen to what other people are talking about. This is the same in the IoT situation. An adversary can easily learn the content of communicated partially through listening on a wide or wireless channel, the latter of which is much more difficult to detect. Because for wireless communication, the signal is in the air. Basically, any people can receive it, can get it. So if those information is not encrypted, for example, if the data, the numbers are just sent directly without encryption in the signal, then any person receive the signal can know the data reading, for example, from your sensor. Sometimes it's not a big deal, but sometimes it can be a big problem. So an adversary will be eavesdropping on network traffic and decipher the content of a message containing information, controls information about the configuration of a network or IoT system. It can lead to a breach of the integrity of the entire system. So sometimes the data being monitored may not be that important. For example, if it is a body weight, you may think it is important anyway. But sometimes, if you're using wireless Wi-Fi, wireless communication, for example, your Wi-Fi, the signal may contain the password of your router. For example, if the bad guy is an expert in this area, he may hack into your router and then do something bad there. So that's the monitoring and eavesdropping attack. So traffic analysis is a combination of monitoring and eavesdropping. So from monitoring the number of packets sent and received by specific devices, it can lead to be inferred information, such as the role of a device in the network or system. Then the adversary device could then behave like a legitimate one, attracting package and rerouting them incorrectly, for example. So it's just like learning the behavior of a device in the network. So it detects what you send, what you receive. So it can identify the role of this device in the network. And then he can generate another device or signal source that behave like this one. And then it can it may overshadow the real one, first of all. And also it can attract some packets. And these packets may be routed to some bad locations, or something has been prepared to collect data. So that's the traffic analysis. Okay, the next, let me see. Okay, the next type of attack is the hole attack. So there are several kinds of hole attack: the wormhole, the black hole, and the sinkhole. So yes, you're right. So these terms comes from the aerospace. A wormhole attack. If you are a fan of scientific novel, you know wormhole, right? Wormhole can disrupt routing by convincing nodes that are usually many hops away from a base station that they are only 1 or 2 hops away. This assumes. So what it does is that there are no definite ways to ensure security against a wormhole. Nevertheless, some attempts have been made to better understand the problem. In the wormhole attack, materials may reroute message received in one particular part of network over network and replay them to a different part of the network, resulting from the nature of wireless communication. It is possible for an adversary to create a wormhole for packets that are addressed to the other nodes and tunnel them into global adversary in another location. What it does is that, so in a network, so if you heard of wormhole before, the aerospace one, so it will suck in the material, right? And then the material will come out from another location. So usually these two locations will be very far away. So if it is in the network, so the wormhole attack, what it does is that, for example, if this device, if this device is infected, okay, then it will attract the packets, and then the packet will be sent out in another location of the network. And by doing this, most of the time the purpose is to reroute the package to another node in the network. Usually this node is maybe a server or a database controlled by the bad guy, so that it can collect the data from the rerouted packets. This permits a further undermine the correct operation of the routing protocol by comparing various routes in the network. It's pretty simple. So basically, the wormhole just redirect the route and redirect the packet according to the bad guy's need. So black hole and sinkhole attack. So black hole, you know what it is, right? Basically, it sucks in everything. So it's similarly, they advise zero rounds to base station or gateway station through a specific malicious code. So for the routing, routing of the packets following the protocol, they will find the shortest routing path from one location to another. Okay, so for routing, the shortest way is from A to B, maybe will be the straight line above, right? And also, of course, you can go different ways if you want. So for black hole attack, so for this, if this node is affected, so when the packet is at the A location, it compares the path distance. So for this rep which is affected, so it tells that, okay, I'm just one step from the destination B. Then the packet will be attracted to the red node here, which is affected. But actually, it just attracts the packet. It does not route anymore. Basically, the packet arrive at the red node will disappear or be destroyed, will be lost. So in that case, this packet is gone. So due to for the network itself, so for the B, it will notice that for the B location, if after some time it does not receive the packet, it will send a signal to A. Then A will know that, okay, the packet is lost. Then A will send the packet again. So that's the mechanism of a network. So if a packet is not received, then it will be informed to the sender, and the sender will send it again. Yeah, this is good thing, right? In that case, the node A will send the packet again, but once again it will be attracted to the red node. So this will keep repeating. So energy is wasted and resources are consumed. And actually, if the red node is not solved, then the message will never receive B. So basically, it takes out the energy and the resource. And for the physical attacks, so this is just what it means. Physical attack, that means that the device or the mechanism physically are damaged or destroyed. This is especially serious for IoT applications because the devices usually are put in uncontrollable environments, right? In that case, their physical integrity can be damaged, can be compromised, because sometimes this device will be put into the somewhere without surveillance, somewhere remote. So in that case, people can damage this device or physically open the device and look into the components, the circuitry in the device, and also maybe there are some secrets there. So a device can be physically tampered with. In that case, it provides that an advisor can extract sensitive information from the device. For example, there are some chips in the device that can be looked into so that some secrets can be found. And cryptographic secrets may be compromised, circuitry altered, and device reprogrammed. So if the device is reprogrammed, then basically for the previous attacks we mentioned, the bad guy can actually insert most of them into the reprogram device, right? So it has been shown that device can be easily compromised within minutes. So what we can do is to use tamper-resistant hardware, but to be honest, most of the time this can only delay the process, but it will not stop the process, right? If the bad guy is so determined. And also some encrypted controller cores, memories can be used. Of course, this will add additional cost. For the physical attacks, the most famous example is the Stuxnet. Basically, by hiding some malicious code into a printer, so it was able to, damage the nuclear plant. So if you're interested in this story, you can search the internet to find out what happened there. But it is a very representative of physical attacks.